f of x is 1 over x plus 1, and g of x is 2x plus 3. So what is f composed with g of x? So this is, first of all, f of g of x. Maybe if I color code this a little bit, it'll make it easier to see what's going on. If I call this one g of x here, and I'm going to do in red anything to do with f. So that is f of, now replacing g of x with the function, 2x plus 3. Now we're going to substitute this into f. So f is 1 over, and then instead of x, I'm going to write 2x plus 3. And then I've got a plus 1 on the end. Simplifying that, I get 1 over 2x plus 4 as my final answer for f composed with g of x. Working the other way, g composed with f of x is g of f of x. That is g of, and f of x is 1 over x plus 1. That is equal to, g of x is 2x plus 3, so it's 2 lots of 1 over x plus 1, and then plus 3, which is just 2 over x plus 1 plus 3. We could simplify that, but we don't need to. Now it's asking us what's the domain and range of f composed with g of x. That's this one here. So let's think about the process that we'll go through to get there. So f composed with g of x, carry on with the colors here, shall we? Means that we are doing g of x first. So g first. And then from g, we're taking that and we're putting it into f. And we want to see what the inputs and outputs are. So what can we input into g? Well, we can input into g any real number. What can we get out of g? We can get any real number out. Now, what can we input into f? Into f, we can input anything except for -1. What can we get out of f? Anything except for 0. But this except for -1 here has an impact on the domain because we can't get -1 out of g. So what value would we need to stop this from being? Well, we need that 2x plus 3 is not equal to -1. That is 2x is not equal to -4, or x is not equal to -2. So here we need it to not be equal to -2. So our domain in this case is going to be all values of x, but x is not equal to -2 because that would give us -1. And then we can't input that into f. And the range is equal to all values of x, all values of y, sorry, that are not equal to 0. Notice that that does actually work exactly what we would expect it to be for this particular function. In this case, the algebraic function would give us the same domain and range as considering this approach.